Hello, this is the December Call the Doctor session with Aleksandar. So this time I'll start with something that didn't work last month when I was having this session. I was trying to demonstrate a validation of HDF5 JSON and it didn't work. And because I don't like when things don't work on my sessions, I want to just briefly visit and show when things work. What I didn't know at that time is that my Conda environment was broken. And in the process of fixing, I learned things with different Python versions and different packages. Some exist in now standard libraries, the ones don't exist for some. Long story short, I fixed the problem. I actually improved HDF5 JSON package because of that for different versions of Python. So just quickly, I will show the validation and then we'll move to the main show. How it goes, let me see, share screen. Where is this? Yes, here. I have so many windows, I have to be careful what I share. All right, so hopefully you see the terminal window. So what I wanted to show is that as part of the H5 JSON package, there is now ability to validate HDF5 JSON using the HDF5 JSON schema that I developed in mid-2020, I think. So there is a tool, and I tried to run it called H5J Validate, very inventive name. And then you basically present a file with the HDF5 JSON, and I already have one that I know is going to fail. And last time I tried to run it, and it failed for some other reasons. Now it's going to run, and don't mind this delay. It's not because of the slowness of execution. There's some security thing on my laptop that I still didn't figure out that slows down the first invocation of everything, but there you go. So now you see that validation failed, and it shows you exactly which part of the HDF5 JSON failed. Like I deliberately here, instead of dims, I use put dim. And also here, instead of HDF5 deallocation time late, I put the E with the caret. And so it's more like H5 deallocation time latte or something, how you pronounce. And anyway, it's failure because it doesn't belong to any of these other known things. And you get two failures. So that's all. I just wanted to show this now that it's working. And that's that. Now I'll stop sharing this.
Aleksandar, a quick
Yes.
question about the HDF5 JSON tool. Is it possible just to export the metadata?
Yes.
Okay.
What's possible is that you can, you don't get the data set stuff that makes the JSON humongous. I had proposed an extension that you actually start getting the dataset chunk locations and other things, but we are still not there in terms of being into HDF5 JSON.
Got it.
So that's that. And so it's a nice intro basically to what I'm going to talk about now, because what I'm going to talk about is HDF5 Distributed, which is the name that I came up with, has not been cleared by HDF marketing team. So don't put much into it. And it's just an idea. At this point, we're just talking about purely an idea, which I thought is good for last session in December, I think. So people can go and enjoy their holidays thinking about this cool stuff. Now let me find the right window to share. Which one is this one? Probably this one. So several of the previous sessions, I talked about HDF5 JSON. And so HDF5 Distributed is very sort of closely related to HDF5 JSON. And I just want to show this diagram that I like to use when I talk to people not familiar with HDF5, and it is lifted from HDF5 user guide. So basically, what I'm talking about is implementing the HDF5 data model into a new storage format. So we're kind of covering this side of things. There is still no specific programming model for HDF5 Distributed, or let alone some kind of software implementation or API to use. So we're just, as I said, it's just an idea at this point, but and it's not a revolutionary idea. It's not really cutting edge. I'm personally aware of at least 3-4 similar formats, not for HDF5, but with a similar idea like HDF5 Distributed. And so they're definitely proven their worth and being useful and being quite popular in those circles that are really thinking seriously and looking seriously into cloud native computing. So this is more to sort of the HDF5 to catch up with this thing, rather than really break the new ground in general. So HDF5 Distributed. So the focus here is that if you think about HDF5 file, HDF Distributed should be essentially equivalent to that. But I'm not going to use HDF5 anymore, file. I'll try to avoid using file at all. I'm going to talk about HDF5 container now to sort of emphasize that we are leaving file systems, all kinds of file systems aside. And so HDF5 Distributed is really geared towards any kind of storage system that supports some kind of key value interface. File systems can be used for that, but it's not only for file systems. So the key is that there is some kind of a key value interface that can be used. The point that I started from is that there's to be a single URL that specifies this HDF5 container. And everything that happens afterwards in terms of data access is interpreted in some way, sometimes most directly, sometimes more in abstract way relative to that URL. So essentially, I want to be able to have a URL and I give people, here is my data, here's the URL for it. And you go straight to the data. And all the other issues, access privileges, who gets to see what, is handled by that backend storage system. It's not really, so in a way, I try to think of it as really equivalent of what you currently have experience with HDF5 file. Is that file part of something bigger in terms of data collection? Maybe, or is just a so thing? How can you access this file? Well, do you have privileges to open, read, or write that file? That kind of thing. So that's sort of the overall design goal. And the implementation is really looking at HDF5 JSON. And as you can see here, in the same way that HDF5 JSON schema, I have to share more than one screen. I now realize that. Let me see if I can do that. Probably have to share the whole thing. It's easier. Yes. So, for example, if you would, what am I looking at? Minimize this. All right. So what I'm going to basically show you here is one example of HDF5 JSON implemented and how it goes. But I'll use this example because I think it's very useful. So as you see in HDF5 JSON, you kind of break down things per groups and datasets. And it's exactly the same part of HDF5 Distributed. I try to name keys that are now grabbing the data or storing the data based on the HDF5 JSON. And so the keys that are defining group metadata are starting with groups and then the identifier of that HDF5 group. It's exactly the same equivalent when you look into the HDF5 JSON. Here's your groups, and here is your identifier of the group. So groups / this identifier, and then everything that gets stored is essentially whatever is here in JSON. That's relevant, of course, for HDF5 Distributed. And it's the same approach with datasets. Dataset, the identifier of the dataset, so JSON. Here again, you see dataset here. You have now identifier of this dataset, and then its own JSON, again, what's applicable to HDF5 Distributed gets into that JSON. And again, this is very common. What's been done now with some other formats. So again, nothing really revolutionary. Only we are using the flavor of JSON that supports essentially HDF5. When it comes to chunks, I have a special key that starts with chunks. And so the format is you have chunks, then the dataset identifier, and then you have this kind of bunch of integer numbers delimited by underscore. And each of these integer numbers is the chunk address in the array. So that, you can pick up them, once you know the data where it needs to be written to or when the data has to come from. And again, I was trying to give this example thinking about file and think about S3, but as I said, those are just examples. Really, any other thing can be used with a proper interpretation. So as you see now, you with a file with the exact file name of where the chunk is, and now this will be an S3 with an exact object where the chunk bytes will be. I mean, again, very, very common these days for this kind of format. The specificity of HDF5 is that you can actually store data types in it. So there is a data types version of these things. But again, it follows HDF5 JSON for data types. I don't have it in my JSON example, but again, it's very similar, how it would go into it. The thing that I think is probably the most controversial or most HDF5 is this fact that you need to support multiple linking in HDF5. As far as I know, HDF5 is the only one of these distributed file formats that has this feature. And so I expect that there can be a lot of confusion why and how, but this is the way to kind of maintain this shortcut so that you don't have to traverse the HDF5 graph of groups and links until you get to what you want. And so you allow people to actually use HDF5 the way how they understand it, which means I give a path name to an object and I get something from it. And so alias part of these keys is meant to be that shortcut. And it's something that needs to be maintained actively. So if something happens, the aliases need to be created. If something gets removed from the file, the aliases needs to be removed. So it has to be kind of the dynamic content there. But so far, that's the best I could come up with, but open to suggestions. But that's really something that you need to have if you really want to be true to HDF5 data model.
Aleksandar, I have one
Yeah.
question with the chunks. Where do you anticipate putting, say, the filter flags for the chunks? Like have they been applied or not?
The filter ones would go into dataset JSON metadata. Some are here. There is a creation properties thing that if you had filters, you would have somewhere here filter part.
So that would describe the pipeline, but I think in HDF5 there's a 32-bit field which tells me whether the filter has actually been applied to the chunk or not. So there could be 32 filters, and there's a binary bit code that says, yes, this has been compressed with the plate or not, and so I think that's actually a field per chunk, if I understand correctly, and so it's a property of the chunk, not the data set.
That I don't know, to be honest with you. I'm not that low level familiar with HDF5 file format. But the chunks that would be stored this way should be compatible with the chunks that would go into an HDF5 file.
Right.
At least that's the intention. But those kind of things, there is a bit that actually says, oh, by the way, for this chunk, I actually applied something or not. I'm actually not familiar with that.
Right, and I think this is one thing that, say, STAR doesn't have. Right, it's either all compressed or all not. Whereas if I just post a link to H5D get chunk info, and there's this filter mask field there that it indicates whether filters can be used or were used. So that means that some chunks could be compressed and some chunks might not be, if I understand correctly.
Could be. I mean, ZAR has two things that, yes, so ZAR is, yes, everything is the same. There are no per chunk variability. The other difference, since we talk about filters, is in chunk world, there can be only one compression filter, and everything else is in some other way modifying the byte or rearranging the byte. There is no possibility that you have more compression filters. There can be only one compression, and that's it.
Right.
Yeah, I don't know about this. It's an interesting point. Thanks for bringing it up. I'm now working through NASA little grant that we're looking at the data quirks of essentially looking at data created with HDF5 library, but accessing it without HDF5 library. I have to admit, they may have found something like this or may not. I have to check twice. But now that you mentioned it, that brought up something that I heard before. But yeah, I would consider it to be a little dangerous, but maybe. I always thought that the chunk bytes are pretty much chunk bytes. That it's not like, oh, by the way, there is something interesting on top of chunk bytes there, but could be.
Yeah, I think, well, part of it, I think, depends on the filter itself, right? How is the filter designed? And I noticed that some plugins might encode some extra information other than just the compressed stream, which actually creates maybe some friction versus, say, ZAR num codecs. So.
Yeah. Well, the other interesting philosophical question is, should we think about the HDF5 library? I mean, HDF5 library does its thing the way it does it, but there has to be another world where the HDF5 library is not front and central in some way. And so, to some degree, you're now talking into data interoperability issues. Like if data is so specific to HDF5 library being able to read it, now I would call that a dangerous situation.
I agree.
And so it's something that needs to be, looked at carefully. But thanks for bringing it up. I think it's a very fair point. So that's basically all about the HDF5 distributed on the overview way. And then I just wanted to, use this JSON, and then I just decided to show one, again, this is nothing, it's just for show, one kind of way how you could store HDF5 compliant data with a data model, but in a file, but it's not an HDF5 file. So I thought about the SQLite. You get a file, but it's not the HDF5 file, it's an SQLite database. And so I basically just read this JSON and then just created things into an SQLite, just again for show. And so I can show you this. We can look into this. And I opened this file. And close this. Yeah. Not seeing people's faces anymore, but anyway, it's taking a lot of my screen. So you can see basically there are a bunch of tables, 4 tables here. And again, just for show, this is absolutely no complete improvisation here now talking about. And I thought container table should have one column called HDF JSON, and what's in that HDF5 JSON with it's kind of information about the general importance. And for example, in that JSON, I put something like a format version and the root ID, which is essentially important, which tells you which of the identifiers for groups actually represent the root group in HDF5. Though there are other ways how you can do it, but I just did it this way. And so the idea is that whoever would handle, for example, SQLite databases as HDF5 handler, you would look here and then say, oh, okay, this is my root group. And then the whole show starts from there, for example. And then the next interesting one is alias, as I talked about. So you have here, you have path names, and then you have essentially immediately given keys of these things, which is connected to this path name. And therefore, the assumption here is that path names would be unique, but those things can be repeated as many times as possible, and you would have them as many things as needed. And then comes the meta table. This is where all these HDF5 JSON describing the groups and everything about groups, and then everything about data sets, including filters, creation properties, chunking, not chunking, all the other things. They would go into this kind of thing where you have an objectee and then you have some kind of JSON. Now, in this particular case, once I removed some content that in some other tables here, there was nothing left for this group. But for example, for this data set, obviously there is much more. As you can see, there is creation properties, all the other things and layouts and all these things, which is again standard HDF5 JSON written out. And so, and then finally we come to the chunks table, and here again you have now identifier of the data set, and you have this 00, which is the chunk location, if you will. And these numbers are actually in chunk units. So these are not the array indexes. These are actually chunk dimensions. So when you have whole array, then you divide by the chunk shape for each dimension. So you have this chunk unit. So you can do it this way. And again, the content is just bytes. And then obviously interpretation of these bytes and what would go eventually to the client application, it's all up to the handler. And so that's basically what's in this SQLite file, or sorry, SQL database. Obviously, what immediately comes to mind here is that once you have something like a database, you could index things. You could kind of lean on those kind of features now. You could also say, well, chunks, because it's just bytes, I can maybe keep somewhere where it's much faster access, and I can keep the metadata part somewhere else. And again, you can play with these things now, because again, you broke up one single sequence of bytes known as HDF5 file, and there are some very interesting possibilities to play with these things. So that's basically that. I mean, the biggest takeaway, I think, is that in this case, obviously you have a naming convention of HDF5 components in the container. And so you don't have to wait for some process to tell you where something is, or have a single process that needs to decide when are some bytes written out. You can basically now distribute this and tell, where your data set, your chunk, you can immediately know what's the key to fetch those things. And so I think that's the sort of the biggest, I think, change, at least in my mind, compared to the HDF5 file. And here I would stop and see if there are any comments or questions, or or people think of. Again, this is just an idea to see if there is any interest in the HDF community about something like this.
Yeah, I find the chunk key kind of interesting because I don't think we have an API to retrieve chunks based on a multi-dimensional chunk index. I believe the two chunk, there's a H5D get chunk info, and that uses a linear index. So only a single number, 0, 1, 2, 3. And then there's a H5D get chunk info by chord, which is offset of the data element. So basically, it's what you have multiplied by the size of the chunk, of the dot product of the size of the chunk. And I mean, while I think I sometimes would have liked to address it like you are here, um, my sense is it would be a little bit more consistent to keep with the coordinate based addressing of chunks, even though that might be a bit challenging. I know it's different internally, but that's maybe my one thought here is if someone were trying to do a one-to-one comparison between the API and these keys.
There is to be, I think it's going to show up in 1.14 release. There's a new function that is supposed to be much faster in retrieving dataset chunk file location. And I haven't double checked twice, or I haven't double checked what I'm going to say, but I think that function is going to return, I think, this kind of chunk dimensions, and not the actual array locations, but chunk location. I mean, we need to come up in the company. We need to come up with these names so we are all unified on what we name them.
Yeah,
but so we are not using the array indexes. We're using the chunk indexes, if you will.
Right. I think you're talking about H5D chunk iter, the chunk iter, which is a
yes,
is faster to iterate through it. And so I've been working on a few pull requests with that function to clean it up and make it consistent with the API. But I think it does use the Dale element index, not the chunk index.
Okay.
In fact, it jumps through like a hoop, when exposing that data to the user to actually do that multiplication. That said, I think I have occasionally sat down and thought, it would be really nice if we could just use the direct chunk index like you are doing here.
HSDS, the HSDS is using this, and that was the main.
Okay.
And also then, since you mentioned ZAR also uses the same thing.
Yes.
Also, the ZAR doesn't use the underscore. ZAR uses the dot. So we have to be different. But yeah. So that's why. So yeah. So maybe you're right. I forgot in time. But I'm waiting now to move this chunky this new function into H5.5. I have my own custom version.
Right.
That we're using for some time, but I now want to push it into H5.5 because again, I need it. I'm using it a lot. So
I see. And so I guess it's the intention that people still go through the HDF5 API to access this data, or are we starting to think that people might try to graph chunks outside of the API?
Well, I mean, that depends how quickly you want this feature, how quickly you want it, and what's the fastest way to get it. I mean, I know, for example, the ZAR world is using alternate way to get to HDF5 data in files, and they're directly dependent on the chunk locations and things. So, as I said, I'm not aware of any software within this company that can do this right now. I think to some degree, what I wanted to talk about this is to see maybe there's this feedback through comments or questions we get. Is there really interest in the HDF community and large something like this? And maybe HDF community is mostly file-based, and so this is kind of something that they don't have really interest in, or maybe there is. But what I wanted to say is that as far as different storage formats for HDF5, we are aware of these developments, and we are sitting on HDF5 JSON, or at least I'm aware of HDF5 JSON for 9 years now. And so, as you can see, from HDF5 JSON to HDF5 Distributed, it's a one-way street very quickly. So I just want to say, as far as discussions going, yeah, HDF can be represented in exactly the same way as some other formats that claim to be cloud native. As far as the software goes, my thinking is it would be nice if a community would organize itself and basically implement something just straight in some programming language. In the programming language where you have a lot of backend storage already supported, and where development is fairly fast, so that it doesn't take a lot of time and attract people because the threshold of skill level is not that demanding. And so build in that way, understanding, is this something sought after? And then we can think, I think, from the company perspective, whether or not you could do something in a better way. Because mostly these days, if you're in the science domain, it really it's much more powerful if you come up with some idea that has community support. If you can demonstrate that there is a community interest behind something, that you are not just saying, hey, we can do this and therefore we think it's going to be great. And so sort of my closing thoughts about this is that I would like that this some idea, again, refined for cases, and maybe this edge case that you brought up with filters and chunks, maybe it's an interesting problem that we need to be aware of. But I would like that the community takes on this and see where it goes. But I would like that we as a company seed that thinking so that people don't come up with 5 different solutions in 5 different unrelated efforts, So
yeah,
that's basically that.
So what I really like about this is the ability to export the metadata from an HDF file, because I think that's what sometimes makes an HDF5 file a bit mysterious, is that people don't necessarily understand how to read the binary format of it. And so just getting that information out of there is really useful. I think there's part of me that thinks that this maybe goes a little too far, though, to be like ZAR. Because and then it inherits some of the issues with ZAR in that all the chunks are individual files, which I think is, for a cloud application is really useful, but on a file system becomes very burdensome. And so, what we're looking at in our internal workflows is the most likely candidate is that our instruments will acquire into something that looks like an HDF5 container, and then might eventually get processed later and published into something that something like this, or something that looks like a SAR, where it's a little bit more cloud friendly per se. But if we could reduce the amount of necessary processing to get from A to B, that also would be great. So I think so something like between this and maybe your previous work with FSpec and Kershunk might be, I think it sounds like it would be close to what the solution I have in mind.
So one of the challenges with HDF5 is that it has so many storage features that no other format has. And so, like, I would love, for example, I think it would be a great benefit if we could essentially use ZAR to encode HDF5. I think people would always welcome say, okay, one format left, awesome. But it turns out that the ZAR started with a much smaller set of features, not much smaller, but smaller set of features. They simplify some things, and so I'm not sure. I haven't looked closely yet, but I'm not sure that you can have the whole thing of HDF5 into ZAR. And so the question becomes, as the HDF group, should we, left behind some people or the more advanced features of HDF5, or you should go forward with this thing that supposedly is much more capable to cover the whole HDF5, all the HDF5 features. I mean, that's the issue.
I think what would be useful perhaps is a sub-specification, right? So obviously SAR does have its community, right? Even with its limited feature set. And right. And so if we could carve out, a subset of HDF5 that is going to maybe has a chance of being a little bit more compatible with ZAR, that actually would be really beneficial, and I've occasionally run into the situation where I would actually really like maybe different levels of HDF5 specification. So, in other words, what is the simplest, a very simple specification that would only give me a very limited set of features, right? But would still be the HDF5 file. That would give me somewhere to start if I wanted to create an alternative library, right? So, for example, what happens if we just wanted to create a mini library that would just write a contiguous HDF5 data set, single data set in the file, and that's it, right? So that's a much reduced feature set, but it actually would give someone a place to start, right? Just to create an HDF5 file. And that would be something much easier to integrate in an instrument control software that maybe isn't very sophisticated. So just to give an example, we have at my institute, we're making custom microscopes, and many of these are run using software like LabVIEW. Okay, and we can go through it. There's an HDF5 plugin for LabVIEW, but that's sometimes too burdensome and introduces complications. And so, what they might want to do is just be able to code in LabVIEW how to write a very simple HDF5 file. And that's a little bit harder than it needs to be right now, because you have to go through the entire HDF5 specification and, figure out, half a dozen different messages and data object structures and different versions of those structures. So it'd be good to just maybe have a sub specification that says, if you implement these things, you could write a valid HDF5 file. And this is kind of the minimum thing. And I think you could do the same thing for, if you use these features, these will be a mostly SAR compatible data set. Something like this.
Well, I mean, it's if you put some kind of library on top of HDF5,
sure,
and that library becomes your actually data IO library, then you are effectively in control of what features of HDF5 you are using. But yeah, I mean, and again, ZAR was a great example of it. If you make specification easy to understand for people, and even if you don't have a single implementation in a language that's easily interfaced by others, people tend to develop implementations because they understand it, they can write it, and things are sort of blossoming very, very grassroots.
Sure.
So yeah, it's a great example, and it's a great challenge to the assumption. What are really the features for storing data cubes? Because while we're talking about the data cubes, if we want to be sort of business buzzword, what is really that famous 80% of features for 20% of effort to store data cubes? And if you can organize effective workflow for a community with those kind of things, then what are we talking about left? I mean, that's why I think ZAR, the version 3 specification, that's why they're using this extension a lot, because they kind of want to say, we don't want to fight, is this feature really crucial or not? If you are so passionate about it, define an extension. And if someone doesn't like it, it comes out to this extension. I don't know what to do with it. Just ignore.
Right.
You know what I mean? I think that's sort of a good, economically viable, if we will, approach to a data format. Otherwise, how can you play full court pressing all the time?
Sure.
It's very, very tiring. So, all right, as always is the case, I have another meeting in 5 minutes. So I thanks for everyone who joined. Mark, thanks for your questions and contribution. It was very useful. And yeah, I mean, people should comment on this. I don't know what's the best way. Probably comment on the forum under the announcement of this session, or info@hdfgroup.org with questions, or I don't know what's the best way. But I would really like to see some feedback and opinions, and really this to be more of a community effort initiated by the HDF Group than a community waiting behind for HDF Group to deliver everything.
Yeah, sorry, I may have missed. Is there a code repository somewhere available that I could?
There is no code for this.
I see. Okay.
This is just ideas.
I see. Yeah.
So,
yeah.
But I'm open to hackathon if that's going to, like a
right.
hackathon of something we organize. Yeah.
Yeah, it would be very interesting. I'm just noticing that the SAR people have had some success doing this completely via GitHub issues, right?
Yeah.
And it does allow for it's a very similar forum experience, but I think it does have some features that also are useful for having some kind of technical conversation. So
fair enough.
That could be another.
Yeah. If the company agrees, we can go that way. Yes, no problem with that. I have no problem with that. All right. Well, thanks everyone. Thank you. Have a great holidays and Happy New Year.
Yep. Happy holidays.
Thank you.